GCSE, the topic is vector proofs. So this is especially a level 9 vector proof question. Level 9 meaning it will be at the end of a paper, and the level of difficulty, it's a maximum difficulty sort of question on any GCSE paper. Okay, it's always towards the end of a paper. So OAB is a triangle, OPM and APN are straight line. This is given to us for a specific reason. We probably need to use it, the fact that OPM and or APM are straight lines. Okay, M is the midpoint of AB. Okay, that's the midpoint of AB. So OA is given to us as vector A, and then OB is given to us as vector B. So this is vector B. And OP to PM is 3 to 2. So always go back and annotate your diagram. So that's 3/5, and that's 2/5. Okay, 3/5 and 2/5. Work out the ratio ON to NB. So what is the ratio from here to, what's the length of O to N? What's the vector there? And then what's the vector N to B? What fraction is it of B, ON and NB? Yeah. Okay, so what we start off with is finding the vector that we can find from these. Okay, the common vector that we can find is vector AB. Okay, vector AB is going to be A to O, O to B. That's going to be minus A plus B. Okay, we found vector AB. It's from a triangle. We can see these two are given to us. The last vector that we need to find, you would naturally find it. That's always a mark. Always find the vectors that you can find. The next thing we need to find is what other vectors do we need to find in order to work out the ratio ON to NB. N is cutting through the line OM. Okay, the common point is P. To get to N, you have from O you can get to N, or what you can do is you can go A. So from A you can get to N, or you can go AO and then to N. Okay, so N is like our target point. So the vector that we actually need to find is, like I said, is cutting through OM. So the best thing for us to find next is OM. Okay, the vectors that you need to find in order to get to the answer, it comes with a bit of practice. So O to A is A, and then A to M is going to be plus a half of minus A plus B. Okay, so O to A is A, and then A to B is minus A plus B, so it's a half of that. And then if you collect the like terms, you're going to end up with A minus a half B minus a half B, half A, sorry, plus a half B. Okay, and that's equals to a half A plus a half B. So this is the second vector we've calculated. It's because the way we need to get to N is that path is crossing, so we do eventually need that vector. Okay, the next thing we look at, okay, we need to get to N. Like I said before, I can get to N as AO and ON, or the second step is the one that's a bit complicated that you need to think a bit more. So AN, I can go AO plus ON, and ON is a fraction of OB. Okay, that fraction, I'm going to call it KB. K is a number, a constant, a fraction, in fact. So ON is some fraction of OB. So the vector, we can rewrite that as, so what we have done is we have taken this part, so we've done A to O and then O to B. Okay, that's the part over here. So then, in order to calculate that vector, what we have here is AO is just minus A, and then ON is, we called it plus KB. Okay. The second thing that we need to do is we need to find AN through another path, a path that we actually do have all the values from. Okay, it's always the straight line that they give you somewhere that's going to come in handy. APN is a straight line, which means the vector AP times some number gives you the vector AN. Okay, so in order to find AN another way, what we are saying is this is the second way. So you're finding an using AP. Okay, so the vector an is some number. Let's call that number p. Okay, we don't have p anywhere, do we? So some number p. Oh, we do have p here. So we'll call it x. So some number x times the vector AP gives you the vector an. So that vector AP, we need to calculate it. So AP is going to be minus a plus, we know the vector here, which is 3/5, the fraction, which is 3/5 of OM, and OM is now coming in handy. Okay, a plus the half b. It's going into the end of the page, but the actual vector is a plus 3/10 of a plus 3/10 of b, and that's going to give us minus 7/10 of a, and then plus 3/10 of b. Okay, that's vector AP. So we're just going to put that back here. So it's minus 7/10 of a plus 3/10 of b. These two vectors, we found two different ways to get to the endpoint, but which means they're both the same. Okay, a turns straight away like this, or using the green path. The pink and green path leads us to the same destination. They're the same vectors, which means the number in front of your a here, which is minus 7, I'm expanding the brackets here, x is just a number of vector a, and 3/10 of xb, they are the same vector, which means the number in front of a must be the same as the number in front of a here, and the number in front of the b must be the same as the number in front of the b here. So all you are then going to do is equate the coefficients of a and b. Okay, coefficients are numbers in front of these letters. So from a, what we can say is that what's in front of a is minus 1. That's equals to minus 7/10x, which means we can say 1 is equals to 7/10x. 7 times what gives us x, 1, 7/10 times what gives us 1, that has to be the reciprocal, 10/7, okay? So x has to be 10/7. So the value of x is 10/7. We can do the same thing for b. We've done it for a, we do the same thing for b. So k is equals to 3/10x. So then x, we already calculated it from a. So 3/10 times 10/3, that gives us 3/7. And this is sort of what we were looking for. We wanted to find the ratio of ON to NB. We found the fraction of the way we need to go to ON. So what they're saying is that O to N to B, this vector is 3/7 of B. That means that vector is 4/7 of B, because OB, that vector is just B. So the ratio is just 3 to 4. Okay. Oops, it's a mistake. Sorry. 3 to 4. That's going to be 3 to, there's a glitch on this pad. So that's 3 to 4. That's your final answer. Okay, so the idea is you find the vector using two separate paths. That's your full solution. So you find the vector using two separate paths. The vector that we chose to find was ON, because the end part that we wanted to get to was N, because that's the bit that they asked us to find, ON to NB. And we use always, is the second part of the problem is always some multiple of a line. Okay, part A is something that you can go around and find it. The first part is, the second part is always some multiple of a line, and then you always equate the coefficients of A and coefficients of B, the numbers in front of A and B. Okay, thank you for watching.